Hello, my name is Zakaria and I'll be showing you how you can use combinations to solve problems with probability. After studying a couple's family history, a doctor concludes that any child they have has a quarter chance of inheriting a gene. If a couple has 3 children, what is the chance that one of them doesn't have the disease? So to solve this kind of problem, what I would do is just label everything. So D would stand for not having the disease, it would be 3/4 chance because here it says that having the disease has a 1/4 chance. So the most straightforward way to go about this is to say 3/4 times 1/4 times 1/4. However, there are many ways for this to happen. It could be that the first child they had didn't have the disease and the other two did, or it could be that one of them had it first, the middle one didn't, the last one had it, or it could be that the first child they had the disease, second one did, the last one did not. So there are 3 ways. A more generalized way to generate all these combinations would just be to say n choose k, or in this case, it would be 3 choose 1, and I'll explain what that means. So n choose k, p to the k, 1 minus p to the n minus k. What we put in the p section would be what we're interested in. So when it talked about doesn't have the disease, we would plug in our 3/4. And then the complement is what 1 minus p represents because that's what we're not interested in. So we would plug in 1/4. And then the n and k, the way you choose that, n is basically how many steps you take to solve that problem. So total of 3 steps because 3 children. And then the k would be the number of steps for the situation we're interested in. So in this case, we're interested in when the child does not have the disease, which is just going to be k is equal to 1. So it'd be n is equal to 3, k is equal to 1. And if you think about the problem this way, anytime you solve this with this formula, it's always going to get the right answer. But let's do a problem that's a little bit more sophisticated. Daniela needs to get at least an 80% on the final exam to get an A in physics. If this is a 4-option multiple choice exam with 20 questions, what is the probability she gets an A with a minimum number of questions? So to do this question, what I would do is first label the probabilities of everything. So to get the right answer correct, it would be a 1/4 probability. And to get the wrong answer, W, would be a 3/4 probability. This is because there are 3 wrong answers, 1 right answer, and every answer has a uniform probability. And so to get the final answer, what we first do is ask, what is n? N is going to be the number of steps to solve this. So we need to do exactly 20 steps. So 20. K is going to be how many steps do we need to solve the special case. So in this situation, how many questions do we solve to get the right answer and get an 80%? It would be 0.8 times 20, which is 16. So k is 16. Our final answer would be 20 choose 16. It would be p, which in this case is c because that's what we're interested in. 1/4 to the 16 power times 1 minus p, which would be 3/4, 4, because n minus k, or 20 minus 16, is 4, and this is our final answer. The binomial theorem is obviously very tedious, so I'm going to demonstrate computer code that can solve everything. So the first thing we do, we have to write a factorial function. We'll write it recursively. Basically, we'll break it down into smaller pieces. So we know that n factorial is the same thing as writing n times n minus 1 times n minus 2 factorial. And we can keep breaking this down from n minus 2 to n minus 3, n minus 4 times n minus 5 factorial. So what we do here is we multiply n times, and then we recall our function for n minus 1. And then what we do for the base case, which is basically when we reach the limit, it's going to be 1. N is equal to 1. If you have 1 factorial, that's just 1. And then what we do over here for this binomial probability section of the function, we're going to calculate our numerator. N factorial, we call the function. For the denominator, we call the function for n minus k, and for k factorial. And then for this binomial coefficient, we divide our numerator and denominator that we have over here. And for the first term, we simply just do p to the k power. So we get our probability from here, probability to the k power. Second term, we'll do the complement, 1 minus probability to the n minus k power. And then we'll just return our answer, which is binomial coefficient, what we obtain over here, times our first and second term. And what we do in this part, we're just collecting information. What is n, what is k, what is probability, and the final thing we do is we obtain our result by calling the function, and we print. Finally, we'll run our Python code in the shell. So the previous question we did for Daniela, we'll plug in 20 for n, we'll plug in 16 for k, and 0.25 for the probability that we're interested in, and then it'll give our final answer. In the next section, Timson will be taking over and discussing coin tossing. Thank you for watching.